Hello students, in this video we'll discuss curves with zero curvature and zero torsion. Let's be given a curve, R of S, in arc length parameter. Here's the first proposition. Proposition number one, the curvature of this curve is zero if and only if the curve R is a straight line, if R of S is a straight line. So straight lines are the only curves that have zero curvature. Let's prove that. The proof goes as follows. Proof, if the curvature is equal to zero, then Fournier-Soré number one implies that dt ds, which is curvature of S times p hat of S, is equal to zero, which says that the derivative of the unit tangent vector is zero, which says that the unit tangent vector is a constant vector. This implies that t hat is a constant vector c1 hat, and that's constant. But remember that t hat is just dr ds, so dr ds is that constant c1. So integrating this, we have that R of S is this constant vector c1 with an s plus some other vector c2, and that's the equation of a line. This is the equation of a line. Great. Okay, now conversely, if R of S is a line that looks like this, then I can do two derivatives. If R of S is a s plus b, then t hat is going to be what? It's going to be a unit vector in the direction of a. So of course, if this is an arc length parameter, then a has to be a unit vector. So note that this vector a, this must be a unit vector, must be actually be a hat because it's an arc length parameter. So t hat is going to be what? It's going to be a hat. That says that dt ds is equal to zero. And though Fournier-Soré number one again, so Fournier-Soré number one implies that the curvature is equal to zero. So we have our first proposition proved. Let's prove our second proposition. So in other words, the only curves that have zero curvature are the straight lines. And that should make intuitive sense. Let's prove proposition two. That is, the torsion of a curve is equal to zero if and only if the curve is planar. Okay, let's prove this. Proof. Assume that the curve R of S, assume that R of S lies in a plane. And without loss of generality, we can assume this plane goes to the origin. Just shift everything to, if the plane does not go to the origin, just shifts to the origin. It's not going to change the fact that the curve is planar, right? So without loss of generality, zero is on the plane. Okay. Then what can we say? Then I know that R prime is a tangent vector to the plane, and R double prime is a normal, so both t hat and p hat lie on this plane. Maybe we should draw a picture to illustrate that. So here's our plane, right? So we're assuming that my curve resides on this plane over here. So there's my curve. My curve resides in that plane. Well, what does t hat look like? T hat's over here, right? That's t hat for my curve. That's R of S. And where's p hat? Well, depending on the orientation of the curve, it'll either be up or down. So let's say that p hat's over here. There's p hat, the unit normal vector. And so t hat and p hat are also vectors in this plane, and therefore their cross product has to be constant. It has to be the normal vector of this plane. So b hat, which is t hat cross p hat, must be a constant vector. Okay? So therefore db ds is equal to zero. But by Fournier-Soré number three, That says this implies that negative torsion of S, p hat of S, is equal to 0, which forces, since p hat is not 0, this forces the torsion to be 0. So if you're a planar curve, your torsion is automatically 0 by Ferney-Strait number 3. Conversely, let's suppose that the what? Suppose that the torsion is equal to 0. Suppose now, assume the torsion is equal to 0. Okay? Then by Ferney-Strait 3, that's going to say that dB, that says that dB ds is equal to 0. So b is a constant. B hat is constant vector. I'll just put constant over here. That's a constant. Great. And now consider r dot b. So if I do d by ds of r dot b, that'll give me what? That'll give me the derivative of r with respect to s is t hat. So t hat dot b hat plus r dot dB ds. I know that dB ds is equal to 0. So this is, and I know that t dot b is equal to 0, so this expression is 0. So r dot b is a constant. So r dot b hat, of course that's a b hat, this is a unit vector, b hat, is a constant vector. Let's call it constant vector a. And that's the equation of what? That's the equation of a plane. So therefore we've proven that a curve is planar if and only if its torsion is equal to 0. And a curve has 0 curvature if and only if it's a straight line. So one nice thing to check is if you have a curve, you should check if there's a linear relationship between the x, y, and z coordinates. If there's a linear relationship between the x, y, and z coordinates, you can automatically conclude that the torsion is equal to 0. Thank you very much.